Welcome students. Here we are going to start a very interesting and important chapter, that is inverse trigonometric functions. So we will start this video with the introduction of this topic, which function is called inverse trigonometric function. Before coming to this topic, inverse trigonometric functions, we should know when a function is known as invertible. Okay, invertible function. Invertible function. As we know, inverse of every function is not possible. Inverse of a function is possible only when the function is 1 and onto function. And then 1 and onto function is called invertible function because we can find out the inverse of this function. So clearly now we understand that we can have the inverse of a function if this is 1 and onto function, and this function is called invertible function. Okay, so invertible function, a function which is 1 and onto is called an invertible function, because in this case only, means 1 and onto only, the function will have its inverse. Here basically we will discuss trigonometric functions. So we should know that trigonometric functions are not always 1 and onto in throughout the domain. This is not always 1 and onto. We'll discuss it later on. Okay. Now, how to understand inverse function? Let a function f is defined from set x to set y such that fx is equal to y. Okay, this is domain, this is codomain, some element is here x, and with respect to this function f, we are getting an image in codomain, or you can say in a range. Then function f is defined, this is set x and this is set y. Function f is defined from set x to set y, and image of element x is y. Okay, so let us suppose that this is 1 function and onto function. Let f be 1 and onto function. Then its inverse will exist. Then f inverse will exist. Okay, we have discussed earlier that function is if 1 and onto, then its inverse will exist, and this function f inverse will be defined from set y to set x. Then the range of the function f becomes domain of the inverse function, and domain of the function f becomes a range of the inverse function. Okay, then a function f inverse will define from y to x such that f inverse of y is equal to x. Okay, then here this inverse function is being defined. So as we discussed, domain of function f inverse is a range of the function f, and range of f inverse is equal to domain of the function f. Correct? If we consider a function sine theta, if we consider trigonometric function sine, then this is not 1 1 and onto throughout the range, but in certain specific part, if we define sine from minus pi by 2 to pi by 2, or 3 pi by 2 to 5 pi by 2, means these are domain, then here range is equal to minus 1 to 1, and in certain part of the domain this sine function is 1 1 and on 2. So sine function is 1 1 and on 2 in this interval minus pi by 2 to pi by 2, and this will be 1 1 on 2 in this interval also. So in some specific areas sine function is 1 1 and on 2, and this inverse will be possible. Okay, and here this is domain of the sine function, and range of sine function will be minus 1 to 1. Similarly, for other trigonometric functions also, they are not 1 1 and on 2 throughout the domain, but in some specific part of the domain, specific areas of the domain, other trigonometric functions are also 1 1 and on 2, and we can say that trigonometric functions are invertible in that particular area where these trigonometric functions are 1 1 and on 2. So now we will discuss it, we will understand it, that which area trigonometric functions are 1 1 on 2, and in which area we can find out the inverse of these trigonometric functions. That's why this is called inverse trigonometric functions. Topic is mainly based on trigonometric functions. Okay, so now we will understand it with the help of a table. We'll make a table of trigonometric functions, their domains and their ranges. These are important to remember, important to understand, then only we will be able to solve the problems from this topic. So now let us frame a table mentioning trigonometric functions, domains and range. This range is called principal value branch. Okay, we will discuss. This range is called principal value branch, and the value of inverse trigonometric function, particular value, is called principal value of that inverse trigonometric function, and that entire interval of the range is principal value branch. So let us make a table here. First column is function, second column is domain, and third column is range of principal values. Principal value. We will start with sine inverse x. Here domain will be minus 1 to 1. This is closed interval, and range is minus pi by 2 to pi by 2. Closed interval here also in range. What does it mean? It means if sine inverse x is defined in this domain, the corresponding values you will get in this range, in this interval, minus pi by 2 to pi by 2. As for example, sine inverse of minus 1 is minus pi by 2, sine inverse of 1 is pi by 2. And in between of these values from minus 1 to 1, we will get the range between minus pi by 2 to pi by 2. Similarly, for cosec inverse of x, this is also minus 1 to 1, and here range will be 0 to pi. Third, tan inverse x, here domain is entire set of real number and range is open interval minus pi by 2 to pi by 2. Next, cosec inverse x, here domain is r minus the open interval minus 1 to 1, and here range will be minus pi by 2 to pi by 2 minus element 0. And fifth, sec inverse of x, this is r minus closed interval minus 1 to 1. You take care, this is open interval, whereas in sec inverse this is closed interval. Okay, and range is 0 to pi minus element pi by 2. And sixth, for cot inverse x, here domain will be entire set of real number and range is open interval 0 to pi. So this table is important. We must remember this table. Trigonometric functions are here, their domain are here, and here range. It means these inverse trigonometric functions are defined in this particular domains only, and will get the principal value inside this range. This is the range of principal value, or you can say this is branch of principal value. This is very important to solve the problems. So remain in touch with these videos of this channel, and hope you have subscribed this channel. Please share this video with your friends also. If you have any doubt, any clarification, or you want to give any suggestion, please write in the comment box. I will definitely see it. I will address it. And if you are enjoying these videos, your likes are most welcome. Wish you all the best.